The reason I kept telling when people are in and they were looking at like these questions for 7 through 10 and said, you know, turn and look at the back and make sure you're understanding that vocabulary. This goes back to the notes on Friday when we were talking about on page 13 and understanding on page 13 the difference between the mean, the median, and when you were talking about your mode, and then talking about the ranges and the interquartile range. That's where this is going from, is on that page 13. So when you look at that, it's okay that you turn and kind of look at these answers as you were doing that, okay? So I just want to make sure you're kind of as you look at that. So today we are going to be using your computers for the spreadsheet. So this is still looking at the analyzing of our data. So we're going to describe the center. We're going to use both the mean and the median. You had to do that in your homework. Mean is finding the average, right? That's when you add them all and then you divide by the number. So finding that average, it's your total of all the data, and then you divide it by the number n that you had. The median, key thing about median is when the numbers are in order from smallest to largest. We're going to be working with order again today when we look at ours. And then it's the exact middle. So describing the spread, we're going to be talking about the interquartile range and the range and standard deviation. Those are the three things that talk about how our data is spread out. I can compare the distribution of the data sets by examining their shapes, looking at the center, and the spreads when drawn on the same scale. So one of the things that we're going to do in the next couple of days on this project is you're going to be looking at some different data, and you're going to want to represent it all on the same scale so that you can compare it. So again, we're going to look at the shape, center, and spread in the context of a problem. We're going to look at our outliers. An outlier to a data is a point that's either way low or way high from the rest of the data, okay? So when we talk about an outlier, it means like all of your data is in this one region, like if you think about a box and whisker plot, it's all here. Then you have this one number way, way up here or way down here. That's going to be our outlier. We're going to predict the effect on the shape, the center, and spread as we look at that. So just review, standard deviation shows how much variation, change, exists within our data. It represents a typical deviation from the mean. Popular measure of variability because it returns to the original units of measure in our data, okay? A low standard deviation indicates that data points tend to be very close to the mean. So when we look at that, a high standard deviation means that they are much more spread out from that mean. So our data is going to be more spread. Standard deviation can be thought of as a standard way of knowing what is normal or typical in a very large, or what is very large and what is a very small set of data. So, analyzing the standard. So, if we look going right down the middle, you see the word mean, and down here you see that X with the line over it. That's our symbol for the average or mean. So it says a typical normal curve is symmetric, bell-shaped curve that represents typical data. The center of the graph, the mean, and the height and width of the graph are determined by the standard deviation. When a standard deviation is small, the curve will be really tall and narrow. When the standard deviation is large, the curve is going to be short and wide, so it will be much more spread out. Approximately 68% goes within the one standard deviation. So up here in blue, 68% of my data, which if I divide 68 and 2 means what percent is on each side? 34% here, right? Put that in. And 34% is over here, right? The next one, you see that red line, and it says 95% of the data will lie within 2 standard deviations away. So again, if we wanted to think of half of 95 is 47.5, right, on both sides. So 47.5 of my data has to be above that standard deviation, and 47.5% is going to be below. This is 95% of my data. And then the last one that they have in green, it says, well, 99.7% of my data is going to lie within 3 standard deviations away. So what I'm doing is each time I'm going to add 1 standard deviation, add 2, whatever that number was for our standard deviation, and add 3. It says if there's an outlier in our data, this might be found. Where would we find it on our graph? Where do you think an outlier would be found on this graph? Way top or way bottom, right? Out of 99.3 or 7% of my data, that's almost everything, right? That's almost 100% of my data points. So if it's an outlier, it's going to be way up here, more than 3 standard deviations away, or less than 3 standard deviations. And we only usually go look at 1, 2, and 3 standard deviations. So let's take a look at the top of the next page. So we have 2 sets of data, 2 different soccer teams. It says the mean of both are the same, but their standard deviations look different. Look at the differences of the shape of the graph. So soccer team A, they are telling us that this U, notice that's really our what? The 66 is really our mean, right? So we could put that as our X with a line over it. This is the other symbol that they use for standard or for mean. And then the other team, Team B, has the same average, right? The same mean, X with that line over it. But this time our standard deviation is 3. It says for each team, 68% of the players are between what 2 heights? So 68% on this one are going to be between, if we are looking at that, what would we say as we look at our data? We would say on the first team, Team A, right? If we are looking at that, we should see between 65, right, going up here. So if we are looking at that, between 65 is 1 standard deviation to 67. Whereas here, we're going from 63 to 69 inches, okay? Much more spread in the second team, right? First team, everyone's pretty much the same height. That's what it's telling us, right? So for each team, what is 95% of the players are going to be between which 2 heights? So this one, we're going out 2 standard deviations. That's our 64 to 68. The second team is going to go all the way from 60 up to 72 inches, right? So when we are looking at those, does it make sense how they got those numbers when we look at our percentages, okay? So looking at 2 standard deviations away, whereas this one is 1. So it says, what does standard deviation tell us about the heights of the player on each team, especially since they have the same average? And this is what I need for you to make sure you write that. If we look at these 2, Team B has more variation in their height. They are probably going to have more taller players, but they also have shorter players, right? They're kind of spread out in their height. Team A has less variation, meaning that their players are closer to the same height. Are great tools for working with data. We're going to use a formula in our spreadsheet to do all your calculations. So what I need you to do is to go to Google Spreadsheets, type in the heading as shown. You're going to, so yours is going to look just like this in your notes. So I'll give you a minute. After you've typed in data set A, B, and C, this data is not in order. Now, is that going to affect finding the average? No. Is it going to affect the median? Yes, because you're trying to find from cell B2, which is where the 9 is located, to 13. And what you're trying to do from B2 in this case down to the 13, which is in cell B6, you want those in order to find the median. Do we need it for the range? For sure for the range, because you're taking this 13 and minusing cell B2 is our formula. Probably not affecting the standard deviation, right? So when we go to your sheet, what you want to take a look at is when you type in your data for set A, please type it in the numeric order, and then I'm going to help you as we put those formulas in. I want to put in the formula for the mean.
So you are on cell B8, and what you're going to do is you are going to start with an equal sign. Now, if you don't start with an equal sign and you just type average, it's going to find the average, but it won't come out to give you a formula. It will just come up with the word average. So I want everyone right now to just type, don't put your equal sign, so delete your equal sign, and just type average. And when you type average, notice it doesn't give you anything to work with. Whereas if you put an equal in front of average, what's really nice is when you start putting equal and then you put average, it's saying, well, which of these do you want to find? And it's asking you all these things. And we keep typing. Do you want to find the average weighted? Do you want to find, we just want the regular average, okay? So you're going to click on that. So when the options come up, you don't want to type the whole word average. You want to choose that option. Does that make sense to everyone? Okay. So now, where are we finding the average from? The nicest thing you can do is click on the cell, and notice it puts the B2 in there. Okay, so you see the B2? We are finding the average from B2, and then what you are going to do is you're going to just drag it down to that bottom cell, to B6. And now you just put the back parenthesis. And when you hit equal, or when you hit enter, it gives you the average. And if I click on the cell where that is, right, it gives me the answer, and up here it shows me the formula. So is the formula the same here? Yes, except you can't just copy the formula. Equal, and I mean there's ways you can do it, but we're going to keep this one. So again, you're finding the average. So you start typing. You click on that word average. Click on the cell. What should the average of this one be? 10. You put your back parenthesis. I went 60, back parenthesis. And we hit enter, right? So let's go down and do, so you'll be able to do for set C. We're going to do our median, right? And because I just had the 5 there, that's what we were looking at. So now we're going to do median. So again, you start with equal, and you start typing median. M-E, oh, median, and it comes right up for you. What are we finding the median of? Again, click on the cell from B2 down to B6, back parenthesis. Which makes sense. We already knew that. Oh, and even though I misspelled range, hopefully yours is spelled correctly. So again, we are going to start with the equal. Now, this is the only one where you really could type it in, but when you find the range, you're taking this cell and you can click on it. And then I put minus, and then I click on what I want to subtract, and I hit enter. And 13 minus 7 is 6. And my standard deviation, again, I'm going to start with my formula with the equal, and I start typing it, ST, and you're going to see many of these, and we want standard deviation. You don't want to type that in. You want the computer to do it. What's that? You just have to click and subtract the two, and I'll go back to that one. So let's finish doing this one. So standard deviation we're finding from, again, you click on the cell B2, and you drag it down to 13, which is in cell B6. And you hit back parenthesis, and we should get this standard deviation, okay? So please try it so that if I am looking at your data, notice it says you can't do this, division by 0. This was 0. So changing those formulas after you put in set B, okay? This will be kind of similar to what you're going to do in your notes. On the top of page 18 in your notes, this is where you're putting that data in after you've put in team B and C, or team A and B. So after you put in this, so don't forget to put it in order. That's how we're calculating our range correctly. But as you look at that, hopefully these are the numbers that you should have had. So if I'm looking at my spreadsheet, 68.3, 68.3, and 1.2.
right? So when I was looking at mine, 68.3, 68.3, 1.2. We're not going to put all those decimals behind for our standard deviation. So when I am looking at those, 68.3, 68.3, and 1.2. Put in the numbers for B and check that you get these same numbers. Yeah. Your notes before you work on your homework. So using the spreadsheets to answer these questions, okay? Josie's algebra grade, so what I would like you to do is to have one of you, let's say this half of the room by the window of this half, you're going to do the algebra one for Josie, and then Kevin's, that's going to be this side. So I don't need you to do both. How many data points are we talking about? They both have 5, right? So do you know where we have C in our spreadsheet, right? Could you just go to set C, or could you go back and change and just put this is going to be, just type in Josie's name, right? And those of you that are doing Kevin, put his name in there and set C, because you already have it going for the 5 cells. So write in your notes on the top of page, or middle of page 18, that's what you want to type in. So those of you that are doing Josie, put Josie's name on your, instead of C. Call this Josie. Those of you that are doing Kevin, put Kevin. Okay, and you're going to put in her test grades, and if you already had yours set up with finding the mean, the equal, the average, you should be able to click and just change those numbers. Okay, when you don't have like 6D, it doesn't know how to get to there, but if we go D6, so make sure you put in your test data. And this is what I'm looking at, those of you that if you've started calculating for Josie and Kevin. So I had, if I'm putting that in my spreadsheet, just make sure whichever person you did, that you are finding that standard deviation, okay, that average, okay. So our mean, median, range, and standard deviation, as we are looking at those. If you are not getting these numbers in your spreadsheet, you want to make sure you check with me. To find 68% of Kevin's scores, we are going to take 80.6, and we are going to add 9.1 for our number here. We are going to take 80.6. and subtract 9.1, right? Kevin had a lot of spread in his tests, right? Josie's were much closer together, right? So to find 95% of Josie's, we have to take 2 standard deviation. So we're going to take her 87.4 plus 2 times the standard deviation, 1.5. That's going to give me this number, right? To find the bottom number, I'm going to take 87.4 and I'm going to subtract 2 times 1.5, or subtract 3, right? So if I was looking at my numbers, we should have, as we looked at that, here we're going to have 71.5, right? 89.7. That's 68% of her tests are within that range. Which we have 88, 86, 87, 5 out of 8 of them. That is 68%, right? 5 out of her 8 tests. But there was only 1 that was a 90. So now we're going to look at Josie's. Ooh, wrong person, sorry. Here, when we looked at these, those 5, this one was not in Kevin's. Josie's, we are going to, again, look at those 2 numbers. We should have 84.4. You agree? 84.4 subtracting 3. And our top number should be 90.4. Which student is doing better in algebra? Probably Josie overall, if we're looking at her test grades. Our answer should be, we want to answer the sentence, we want to support our answer with at least 2 statistics. So you want to tell me something about Josie, you want to tell me probably that her mean and that her standard deviation was 1.5, right? You want to possibly tell me that her median test score was higher than Kevin's, right? And her range was definitely a lot smaller. So you want to write a sentence, and when you're looking at your answers in the back of the book, you're going to see more of them. So your homework tonight